Lesson 4.1, Factors and Prime Factorization. A prime number is a whole number greater than 1 that has exactly two whole number factors, 1 and itself. Composite number is a whole number greater than 1 that has more than two whole number factors. Example of a prime number would be 1, since the only thing that divides by 1 is 1 and itself 1. 2 divided by 1 is the only thing that divides into it. 3, 5, 7, 11, 13, and so on. Again, you're looking for when you divide the number, you can only divide by 1 and itself. Composite numbers are like the number 4. You can divide it by 4 and 1, 2 and 2. The number 6, 6 and 1, 2 and 3. 8, 4 and 2, 8 and 1, and so on. Prime factorization is when you write a number as a product of prime numbers, you are writing it as a prime factorization. We will talk more about that later in the section. A factor tree is a diagram used to write the prime factorization of a number. A monomial is a number, a variable, or the product of a number and one or more variables raised to the whole number powers. Example of a monomial is the variable x, or the number 4, or the number 125. Any type of variable, even products, which is like x times y. Those are two variables multiplied together. Or 4 times x. Anything that is multiplied together is a monomial. What is not a monomial is when you have 4x plus 5. 4x is a monomial, 5 is a monomial, but together it is not a monomial. A rectangle, for example 1, has an area of 18 square feet. Find all possible whole number dimensions of the rectangle. We can write 18 as a product of two whole numbers in all possible ways. We have 18 times 1 equals 18. We have 9 times 2 equals 18. And 6 times 3 equals 18. These are the factors of 18. Factors are the numbers that can be multiplied together to equal 18. This is also, the factors are also the dimensions of how to find a rectangle with an area of 18. You can have a 6 by 3 rectangle, a 9 by 2, or an 18 by 1. Remember, the area of a rectangle is length times width. Example 2. Write the prime factorization of 420. We use a factor tree to write the prime factorization. 420 is 10 times 42. You're basically trying to get 420 into only primes. 10 becomes 5 times 2. 42 is 7 times 6. And we keep doing this pattern until we only have prime numbers. As you can see, 2 is a prime number. So we can bring that down one more time, or sometimes you can just circle it. 5 is also a prime number. Circle it or bring it down. 7 is a prime number. 6 is not, because you can continue 6 by doing 2 times 3. Your prime factorization then is 2 times 2 times 3 times 5 times 7. You can see I put them in order from least to greatest. I also can continue, and officially my prime factorization would be 2 squared, because there's 2 2's, times 3 times 5 times 7. That's your prime factorization. You're not multiplying them together, because if you multiply them together, you're going to get 420, which was the whole point, was to factor it out until it's only primes. Another possible factor tree is 6 times 70. 6 becomes 2 times 3, which again are primes. 70 is 7 times 10. 7's a prime. So you can circle them and bring them down. 10 becomes 5 times 2. You can see that no matter how you solve the factor tree, you're going to get the same result. And again, there's the 2 squared times 3 times 5 times 7. That is your answer. To factor a monomial, it's a little bit different. What you need to do is you need to expand this x to the 4th power and expand the 24 by using a factor tree. So let's start with the 24 and make it a factor tree. I'm going to do 6 times 4. 6 becomes 2 times 3. 4 is 2 times 2. 2 is a prime, 3 is a prime, and these 2's a prime. So what you have here is 2 times 2 times 2 times 3. Now you need to expand this x to the 4th. Well, that's 4 x's. So you have 2 times 2 times 2 times 3 times x times x times x times x, and then times y. This is factoring. We call it factoring a monomial. You're going to write all factors of the number. When you write all factors, let me just give you a quick refresher. If I was writing the factors for 12, that would be 1 times 12. And I kind of make a list. Somebody called it a rainbow. You're going to connect them, but they're going to be at the end. So 1 and 12, 2, and then that's 2 times 6, 3 times 4, until you kind of meet in the middle. So that's what you want to do, and you can see that's kind of a rainbow because you're going to connect these. You don't need to put that, but you want to space them out, and as you go through your list, you'll get closer and closer to the middle. Try number 1 and 2. Number 1, we have 1 and 28. Go through the numbers. You can definitely do 2 because 28's even. That's 14. 3 we can't do, but we can do 4 because 4 and 7. No 5, no 6. So I'm done. I have 1, 2, 4, 7, 14, 28. For number 2, 1, 48, 2, it's even, 24, 3, 16, 4, 12, 6 and 8. Again, be careful to make sure you don't miss any. Number 3 and 4, you're going to tell whether the number is prime or composite. Remember, prime has just 1 and itself as factors, where composite has more than that. If it is composite, you need to write the prime factorization. And to do that, we use a factor tree. 97. Figure out, is there anything that goes into 97? It's not even, so it can't be divided by 2. But can it divide by anything else, like 3? And if you need to, just take a second and try to do some. No, that's not going to work. I'm not going to get even number. This one is prime, actually. 97 is prime. 117. Again, don't just assume that it's prime. This is an odd, so it's not going to go into 2. Let's try 3. Oh, that will work. So 39. So yeah, it's definitely composite. Oh, we have to do the factor tree. Hopefully you did that. 3 and 39. 39 becomes 3 and 13. So you have 3 squared times 13. Factor the monomial. Remember, the word factoring, I always think of factoring or factor. I always think of it as expanding the numbers or the variables. 21, let's make a factor tree. 3 and 7. Oh, that's it. So we have 3 times 7. And then the n is 5 n's. Number 6, we have, well, we can do a couple of things. We can do 2 and 9. 2 is prime. 3 and 3. And 3 is a prime. So we have 2 times 3 times 3. And again, we're expanding. So we're not going to do 3 squared. We're going to expand it out. Times x times y times y times y.